Another important chapter what I need to discuss is crude oil or petroleum product, how petroleum is made. That in a book they have given about crude oil. Actually, it is related to hydrocarbons. So, what are crude oils? Crude oils are nothing but they are the fossil fuels. They are made by dead and decay of animals. When the animals they get buried deep inside the earth, slowly by enzymatic activity, by climatic activity, they are converted into petroleum, and that's why we call petroleum as fossil fuel. So here, petroleum is a fossil fuel. It's a mixture, and it contains so many hydrocarbons with large chain. And all these fractions, the important thing is all these fractions they have different boiling point, and this property we are using to separate them, and we separate them by the process of fractional distillation. Something very important. So it's a mixture, and it's a dark colored viscous material. Here, how it is found inside the earth, inside the layers of earth, it is found. It is being trapped in non-porous rock, in porous rocks, in between porous rocks and non-porous rocks here, and above oils, always natural gas is found. So they make a hole on it, they drill it, and then they bring out. So the important thing is Jihad Akbar. I mean, the important thing starts now. That's called as fractional distillation, by which we can remove the fractions. So fractional distillation means it is having a big column. That's called as distillation tower or fractionating tower. This is the tower, and here different temperatures are maintained, and here this is having here this portion, it is called as furnace. Here the temperature is very high. All the petroleum is allowed to pass over this furnace, and all the petroleum is converted into gaseous state, and they start rising up. And here we have maintained different temperatures. At different temperatures, different hydrocarbons, different fractions will condense and will come out. So here crude oil enters inside in the furnace, and it will enter inside the tower and will start rising up, because they have different boiling point, and so all the vapors they are lighter, so they rise up. So this is the way how they pass. So the hot vapors, they are moving up, they travel up, and then as they cool down, but still some of the material is still in liquid form even at higher temperature. That's called as bitumen. It's useful for making waterproofing of houses, construction of roads, and many more uses. After that, lubricating oil is there, diesel is there, paraffin is there, petrol is there, and the topmost is petroleum gas. The vapors which are still at gas, they are petroleum gas, and they are used in cooking of food in our houses. So this is all petroleum gas. Will have the if you move from top to bottom, or from bottom to top. Okay, let us talk about top to bottom. Petroleum gas has least number of carbons, and then if you go to petrol, more number of carbon, more number of carbon, more number of carbon. So number of carbon increases, so the boiling point also increases, molecular mass also increases, boiling point also increases. So at different boiling points, at higher boiling point this will come out, at low boiling point diesel, and then low paraffin, and then petrol. This is the beauty of this fractionating column, that it can separate so many things like this. Otherwise it's very difficult to separate them. So if you move from top to bottom, molecular molecules have lower boiling points. As you go up and the down, they have high molecule. Now the molecules are more volatile. Top one are more volatile, and the lower one are less volatile, because they are heavier one. They have high molecular. Even the viscous, the bottom one are more viscous than the top one, because they have high molecular mass. Now this is the table which will tell everything about the fractions of petroleum products. Like, see, if you have like at 40 to 100, you will have gasoline, petrol, and it's only number of carbon only 4 to 12. Here next one is naphtha. It is 4 to 7 to 14, and uses like petrochemicals, medicines, drugs. And at high temperature like 150 to 200, kerosene you will get, and only 11 to 15 number of carbons are there. Aviation, like rocket fuels. Gas oil is 15 to 19, temperature increases, and here is central heating 350, so it is 20 to 30, lubricating oil 30 to 40, fuel oil 40 to 50, waxes and grease candles they are made, and above 50, if the number of carbon is increasing, boiling point also increases. The boiling point is above 400, like bitumen, road surfaces, roofs, road surfaces. So these are different fractions, they are different uses, number of carbons, and the names. So most of the time in IGCSE, most of the time the questions are based on this. Many times they give the diagram and they ask the fractions, or maybe they skip some fractions, and mostly they ask what property is used. So it is boiling point. The property used is boiling point. So this is how different fractions they are there. How what is cracking? Cracking is the technique by which higher hydrocarbons are broken into smaller and more useful one at high temperature and high pressure in presence of a catalyst. So for example, we have got this higher hydrocarbon, the vapors will be there, and in presence of catalyst it will be broken into simpler ones. More, so they are these simpler ones, they are more useful than the higher one. So this is how, it can be done in many ways, like 4 and then 5, then like 7 and then 2. So this is called as cracking of higher hydrocarbons, cracking. So in fractional distillation, process of cracking takes place. So actually it gives a mixture of, if it is alkene or it's an alkane, higher hydrocarbon is an alkane, so it gives you a mixture of alkene and alkane. Sometimes hydrogen is also produced. That's the end of this chapter.